In this, the second lecture over 10.3, we'll focus on calculating resonance charge and using the results to determine the best Lewis structure for a molecule or ion. Let's begin. Sometimes it is possible to draw multiple valid Lewis structures that are not equivalent. In these cases, we use formal charge to decide which structure is the better representation of the real molecule. Think of formal charge as a type of electron bookkeeping. We consider the number of valence electrons the atom brought into the molecule, then subtract the sum of half of the electrons shared in bonds plus the number of electrons on the atom in lone pairs. Using formal charge helps determine which possible structure is more energetically favorable. The goals are to keep the formal charges at a minimum, aim for a small or zero formal charge on the central atom, keep negative formal charges on the elements that have higher electronegativity values, and keep the positive charges on elements with lower electronegativity values. Let's work through an example. If we calculate formal charges for structure A, we see that oxygen has a formal charge of 6 valence electrons minus half of the 4 electrons contained in the double bond minus the 4 electrons in lone pairs for a result of 0, which is ideal. Carbon comes in with 4 valence electrons and has 4 bonds in all 3 structures. For this reason, carbon has a formal charge of 4 minus half of the 8 electrons shared in bonds to equal 0. Focusing again on structure A, the formal charge for nitrogen is 5 valence electrons minus half of the 4 electrons from the double bond, so 5 minus 2 equals 3 electrons. Then subtract the 4 electrons contained in the 2 lone pairs for a -1 formal charge. Take a couple of minutes to run through the formal charge calculations for structures B and C before continuing. Reviewing the results of our calculations, we see that structure C has higher formal charge and has negative formal charge on nitrogen rather than oxygen. It is the least likely structure. Both structures A and B have low formal charge, but structure B places the negative formal charge on oxygen, which is more electronegative than nitrogen. Therefore, structure B most closely resembles the true structure of cyanate ion. Let's try another structure from start to finish. Let's build the Lewis structure for dinitrogen monoxide, N2O. Step 1. Sum up the valence electrons. We have 2 nitrogen atoms with 5 electrons and 1 oxygen with 6 electrons for a total of 16 valence electrons to place in this structure. 2. Select the central atom and arrange the other atoms around it. Nitrogen is less electronegative than oxygen, so becomes the central atom. 3. Draw single bonds between the central atom and each terminal atom. Connecting the atoms together with single bonds uses up 4 electrons. Step 4. Distribute the remaining electrons to outer atoms. We have 16 electrons total to place, and we've used 4 so far, so we need to place 12 more electrons. The outer atoms get lone pairs first, so let's add 2, 4, 6 around the outer nitrogen and 2, 4, 6 around oxygen. Step 5. Assign any remaining electrons. We just place the remaining 12 electrons around the terminal atoms, so there are no more electrons to place. Step 6. Move lone pairs to create multiple bonds if the central atom has less than an octet. The central nitrogen does not have an octet of electrons, so we can move lone pairs of electrons 3 possible ways. First, we can move a lone pair of electrons from both terminal atoms to give nitrogen an octet. Second, we can move 2 sets of lone pairs in from the oxygen to create a triple bond. Third, we can move 2 sets of lone pairs in from the nitrogen to create a triple bond. Which structure is correct? For now, let's focus on finishing the Lewis structure drawing. Step 7. Verify duets, octets, and the total number of valence electrons. In each structure, all 3 atoms have octets. The central atom has either 2 double bonds, an octet, or a single and a triple bond, an octet. Terminal atoms have either a double bond and 2 lone pairs to achieve their octet, or a single bond and 3 lone pairs to achieve an octet. To decide on the best structure, we need to consider the formal charges. Practice doing this on your own for the 3 structures before continuing. Alright, now that we have 3 structures labeled with formal charges, which one is most like the real molecule? Both the left and central structures have low formal charges. The central structure places the negative formal charge on oxygen, which has higher electronegativity, and the positive formal charge on nitrogen with its lower electronegativity. The central structure most closely resembles the true N2O molecule. As always, I'll leave you with the parting thoughts of the authors. Part 1 of this review can be found with the previous lecture on resonance.